Well, good afternoon. We are continuing to fill the auditorium again, so please make your way in. It's almost 5 o'clock somewhere, so enjoy yourself. I think it's going to be a really interesting topic. I see folks are piling in from the lobby, so we're gonna keep giving them time here. The topic today on this one is CrewCom, right? Wireless comms. We found so far in the last 3 weeks, we have found that RF by and far is a hot topic. People, why we've all come to believe and understand that wireless is going nowhere. It is here to stay. So we have fully embraced that over the years, obviously in the live production environment. I was having a discussion with somebody about the wireless versus wired packs and where when we return into our given fields of work, I think we see an even greater increase in wireless packs, number one. I do believe that they will overtake wired positions sooner than later. People want the mobility. Imagine coming off of this this kind of imposed break that we're having right now, and we've had the freedom to move about, and all of a sudden now I'm going to have to sit in one place. Well, Pete Mack and I, we've been sitting in one place a lot, but a lot of people in our industry have not had to. And that need, that desire to be agile, to be free. Our producers, when you think about it, you know, the executive producers and the people we're working for, they live on these wireless devices, the wireless headsets and the comms. So an incredibly important part of our workflow, and Pete can talk about this in a minute, but you know, the people that hear, if they're having issues, that's us, the audio department, and we're ready for it. That's what we do. I can't believe it, but I'm ready to have somebody complain at me for a while. That means I'm working. So anyhow, I'm gonna shut up and turn this over to Mac here so he can talk about the question and answer. And then guys, obviously we see your names on there, but I'm gonna let Pete, you know, kind of talk to you for a couple minutes because he has obviously a long relationship with many of you. And I have a little shorter time, but I really appreciate everybody coming on today and sharing with us about the product and, you know, really giving us a good idea of how we're going to apply this in the future. So Mac, I'm clicking off and you're up.
And I'm clicking on. So welcome everybody. I can see by the people who've been able to log in that we're having, we seem to have gotten over GoToWebinar's login issues where a few hours ago we had difficulty with that.
Yeah, we broke 100.
So welcome everybody again. Glad you're all here. During the presentation today, you will be able to ask questions at any time. They will probably not be addressed immediately, but in your control panel, which on my computer is on the left side, there should be a pull down tab of questions. And if you open that tab, you can ask questions, and as we can, we'll answer them. Hopefully we'll be able to get to most of them. Rarely are we able to get to all of them, but we will get to as many as we can and just put them. Yeah, good to see you too, Dave Zamet. Get them into the question queue. Hopefully we'll be able to answer them in a timely fashion so that we will know what they relate to versus what's being discussed at the moment. And that's about it for Q&A. And I think, Pete, it's time for me to click off, and let me hand it over to you.
Okay, got it. I wanted to, we do all this from one iPhone because our scripts are on there. We just pass it back and forth. First of all, I want to say that my first introduction to CrewCom was with CP Communications when I did a show with them. And I had seen it on a couple of NABs, but never really had a hands-on experience. And that was eye-opening and truly amazing. And at the end of this presentation, I'll tell you about a show I used it on where it basically saved the show. So why don't we just go ahead? Peter, it's you.
Thank you, guys. It's nice to meet all of you guys that are listening to us today. Appreciate you being here to hear about our products. I'm Peter Amos. I'm the owner and president of Pliant Technologies, but Pliant Technologies has been in existence since 2015, but we are a wholly owned subsidiary of my other company, which is CrewCom LLC. And some of you may have heard of us, but we do wireless communications for football coaches, both at the high school and college level, and even in the past had done work in the NFL. But that is our core competency is wireless comms for specialty applications. And we have about 100 employees here in Auburn, Alabama, have some employees scattered about, as you see on the web here, for sales and support. But we, before we got into building our own products, we actually worked with Telex for a long time, selling Telex products and technology to our football coaches before we started designing our own unique products that we really try to focus on products nobody else is doing. We try to do something different, something to add value to the marketplace that no one else is doing. We have our own in-house engineering and manufacturing. We do the bulk of the manufacturing right here in Auburn, Alabama. All of our service work in-house and support. CrewCom is not our first product into this space. It is our second foray. The first was Tempest. We owned a product named Tempest that we developed back in 2008 and launched 2009 that we did under an OEM relationship with another manufacturer. But that product, Tempest, was very successful. We launched that product in both 2.4 megahertz and 900 megahertz, and we sold over 30,000 belt packs worldwide of that technology. So it was, for a first product for a company like ours into that space, it was pretty successful. So when we wanted to look at the next gen of that technology, the three things that I tasked my team with were, I wanted a system that the belt pack was smaller, that sounded better, and went further. And so we tried to tackle all of those different elements of the Tempest shortcomings, even though it was a very popular, very successful product. We wanted to tackle all of those things, and the output of that was CrewCom. We do have a dedicated sales staff for Pliant that it works through our rep firms and our dealers, and they'll introduce themselves here in just a few minutes as they go through the content. We do have a new product called MicroCom. That's a new entry-level product for some applications that need a very small scale wireless intercom. And lots of other cool things coming in, some firmware updates and things that our guys will talk about. I am going to turn this over to my team, but I appreciate you guys being here and giving us your attention today, and I hope you find it interesting. We're here to help you guys be successful. Please let us know what we can do to do that. Thank you, Pete.
All right, thanks, Peter. I'm Gary Rosen. I'm the Vice President of Global Sales, and we're going to talk about a number of different things today. My partners in crime for Pliant, Tom Turkington, who's our Vice President of Technology, kind of steers the boat in direction of the product, of the interface. Mark Rehfuss, who's a Regional Sales Manager, handles about half the country for us, and Art Gonzales, who is our Business Development Manager and also handles the other half of the country for us for the most part. So we kind of divide up, but all of us are technical. All of us are technical presenters, as well as handling, sales and other tasks. And so we kind of work well as a team. I just want to do a quick review of what we're going to cover today. One of the things is with CrewCom is there's only a few manufacturers that do wireless intercom, and there's a reason for it. It's a modest sized market, and it's very difficult to do. This is not easy technology. Also, you'll find that of all of the systems, the way they approach what they do, both in audio design and in RF, dramatically different than one another. About the only thing they really have in common is the fact that you can talk and listen. and how they go about that and get there are very different. We have some very unique properties that we're going to take you into today, show you why we do things the way we do, but we try to make it easy. If it isn't easy for the customers, then we don't do it. We over-engineer in order to make the interface simple. The belt pack you see in front of you is one of the simplest devices. We'll talk a little bit more about that, but it's a very easy, zero training, zero transition time. You hand it and walk away. But we also provide other customer benefits. For example, we don't have any license fees. You don't have to buy the hardware and then in addition, try to figure out how to get it running by having to buy the license for the software. Also, as we do version ups and we include new firmware and software, we don't charge additionally for the new features. We enable them, but the idea is that we'd like you to buy our hardware and we want to make it easy for you. One of the other things that sets us apart from the other systems is that frequently the wireless systems are really an accessory to a wired intercom system. And even the larger scale systems that can be matrix based and may also have a quote standalone, it's not really a system that builds up. They all have standalone, we can do a few. And as soon as you get into a modest size system, suddenly you run into capacity of routing and anything selective you need to do, and you wind up adding not only having to add a matrix and an operator, but significant cost to do a job. So we handle that differently, and Tom will take you through the conferences. And the fact that we do everything based on a network, we have a proprietary network with some very good reasons for that. So we'll go into the system components. I'll show you a little bit about setup and deployment, CrewWare, our operational monitoring software, and some more about the unique RF architecture. So with that, I'm going to turn it over to Tom, who's going to take you through CrewNet, the network architecture, and some of the unique properties.
Thanks, Gary. As Gary mentioned, when we set out to design this product, we really wanted to approach it from something that was easy to use, but also that was powerful enough to handle the needs that our customers have. I started off a million years ago in a rental application, and running a rental house is something that allows you to see a lot of varying applications and some that are very, very challenging. So we designed that, and I'm always thinking about, look, what would a rental house do? How would they use it? What's this happening? So we took a different approach to designing CrewNet, and it's a network backbone, but it is a proprietary network. And sometimes I'm asked, why did you go proprietary versus AES-67 or some other sort of standard network? And we wanted to build it for a purpose-built application. And when we did that, we realized very quickly that even though some systems allow you to use standard networking equipment, almost all of them require that you have a dedicated network. We have a customer, a very large customer, as I mentioned the name, you would all know, that has both CrewCom and another product. And they bought the other product thinking that they could use it on their network. They have a very good, robust network. And they quickly found out that they had to build a parallel network to their own to be able to use that. And it ended up costing them quite a lot of money and really didn't work out the way they had hoped that it would. And so what we tried to do is allow people to use a purpose-built set of hardware and still use the cabling infrastructure that they would typically use for a network to get things done. So we also wanted to approach this whole system to be more than just a wireless system, which is what Gary talked about. Excuse me. So we took the approach of having a decentralized network. And that decentralized network, unlike a matrix, matrices are great. They've been around for a long time. They allow you to talk the way you want to and do those kinds of things. But essentially, what a network or what a matrix does is makes you route everything back to a central location. And what we've done is we've used a distributed set of architecture that helps you save time and money in cabling, and doesn't make you route everything back to a matrix, but still gives you the opportunity to have matrix-like operation where you control different aspects and do those kinds of things. And it also is, our network is frequency agnostic. And so right now we have 900 megahertz and 2.4 gigahertz radios, but we're always looking for appropriate spectrum, whether that be 1.9 DECT or 5 gigahertz or 3.7 or something else. We're always looking and always developing new radios to be able to put onto that network. And with CrewCom, you can have one, the other, both, or future radios all in the network at the same time. So a truly distributed architecture. Art, I'm actually on slide 9 now. So one of the things that a truly distributed architecture does is it doesn't really matter what RP, where the RP is paired or where it's being used, which RT. It doesn't matter which channel or which CU the physical channel is connected to. All the RPs have access to all of the audio resources, all of the resources on the network, regardless of where they are. And that makes for just a really very powerful kind of situation. We then control what the specific RP that you're using, we control how that's being used and what conferences, I'll get into those here in a minute, you're listening and talking to by profiles. So we can set those up for individual users or groups of users, however that works best for you. And so we have this fully configurable, fully reconfigurable architecture that truly is distributed. As Gary mentioned, one of the things that we tried to do is combine 4-wire and 2-wire in the sense that we wanted to give you the ability to use the power and performance of a 4-wire matrix, but kind of make it easy like a 2-wire system is. And our approach to doing that is really what we call a conference. And conferences, you can think about as a party line intercom channel. You can think about as a virtual party line. But essentially what we're doing here is we've got some number of conferences that you can create on your system. We allow you to do up to 64 right now. That number will expand as time goes on. But as you're on a specific conference, you have some number of belts that are subscribed to that conference. And that, again, happens through the profile. And the people on that particular conference can then talk to each other. Then you can create a physical connection from that conference to the outside world via our 2-wire or 4-wire ports on the back of the control unit. And you can do that through a number of different locations. And then you have this audio conversation that happens among wireless users, among wired users that are connected there. And again, we call that a conference. Now, if we have a 2-conference belt and a 4-conference belt, like you see currently right now on the screen, those 2-channel belts or 2-conference belts and the 4-conference belts have access to any 2 or 4 conferences at any given moment in time. And again, the profile sets up how you do that. You press the talk button to talk, you use the volume button to listen. One of the things, as Gary talked about earlier, you can hand this belt to any day hire that you want, and they'll understand how to use it immediately. There's a talk button for each channel, there's a volume for each channel, and that really makes it very easy and sort of intuitive to use.
Tom,
Yeah.
1 second, we've got a couple of questions because we're unfortunately used to using shorthand, and so people are asking what an RT is, what a CU is.
Yes, good call. Good call.
Yeah.
We're going to go through that later in the presentation, but for right now, an RP is a belt. So what you're seeing on the screen right now, we call it a radio pack, and you're seeing a 2-channel radio pack up in the corner and a 4-channel radio pack down toward the bottom. And then an RT is what we call a radio transceiver. That is what actually allows the wireless belt to connect into the system. So the wireless belt is out roaming around between some number of RTs, radio transceivers, that are connected back into the system through the proprietary network. So that's essentially the terminology that we're talking about. But Mark is later going to show you each of those products individually. So as you go through this idea of conferencing, it's pretty familiar, I think, with what you're doing now. We just call it a slightly different term. So, and again, probably the most important aspect is that regardless of where a belt is, we call them radio packs, wherever a radio pack is, anywhere that you have coverage, it doesn't matter which radio transceiver that you're connected to, it doesn't matter what physical port that the hardwired intercom is coming into on the control unit, that pack has access to its designated conferences regardless of where it goes. The other kind of different thing that we've done is what we call ISO. Now, everybody's familiar with ISO and what it is and how it works, but typically in wireless products, ISO has been sort of a very limited functionality kind of idea. We tried to make it a little more useful and a little more wired-like in its functionality. So what we've done, every conference is capable of having an ISO channel associated with it. You can use, Art is going to show you later in the software how to enable or disable ISO, but each conference is capable of ISO, although you don't have to use it. And what it does is it really doubles the functionality of your pack. If you have a 2-channel pack, you really can have 4 conversations. And if you have a 4-channel pack, you can really have 8 conversations. And you press the front of the volume control there, as you're seeing on the screen, to initiate the ISO. So it's really very easy and intuitive. So let's take a look at how ISO works. We have conferences, and in this case, we're going to look at the lighting conference. And you have some number of people on the lighting conference. So from an ISO perspective, let's say we wanted to have the board op and the lighting designer just talk to each other individually while still monitoring the lighting channel. They could do that using our ISO feature. And so one of them would push the front button there, and the 2 of them would be listening to each other while they still listened to the rest of the conversation on the party line, but they could have a private conversation. And of course, that could be just 2 people on a conference, or it could be any subset of the number of people on a conference. So really what we've designated is an ISO is a subgroup of the people that are currently on your conference. And that subgroup can be, you can identify who you want to be a part of that subgroup at any given time. So that kind of allows you to have this second intercom channel for each conference that we have for point-to-point operation or even many-to-many type operation. And that's pretty much the conference side. And I think Mark is actually going to take you, or Gary, I think, is going to take you through the next section.
Nope, it's Mark.
Mark, sorry, okay.
It's me.
All right, thanks, Tom. Yeah, Mark's going to take you through the operation. Our apologies. We all get a little bit too comfortable with our internal terms, so it's easy to use the acronyms. We'll try to use the real titles from there going forward. All right, Mark, all yours.
All right, thanks very much, Gary. So I'm Mark, and I'm going to run you through the hardware that makes up the CrewCom system. And here we have a lovely family shot of all the individual devices that you put together to make this thing work and make the rubber hit the road. Next slide, please. The CU22, which is the top back jack plane you see there, and then beneath that is the CU44. We offer 2 different control units, and one of them has 2 2-wire and 2 4-wire inputs, and the other one has 4 4-wire and 4 2-wire inputs. The control unit establishes the network, establishes the backbone of the entire system. Each control unit will support up to 18 radio packs, and you can stack 4 of those on top of each other to have a maximum of 72 full duplex radio packs in operation on any contiguous CrewCom wireless intercom system. And also our 2- and 4-wire ports are simultaneously functional on each of the control units at any time. Next slide, please. So now we've simplified it to this is the back of the 4x4 control unit. And we have an excellent hybrid internally which allows for auto nulling and echo cancellation. And then starting from the right side of your screen, we have the LAN connection that allows you to connect the computer onto the system and monitor or reprogram the system. It's free software that's available for download at our website, plianttechnologies.com. Then next to that, we have an auxiliary in and out, 1/4 inch in, TRS or tip sleeve, line level, +4, -10. Takes anything you need to put in there and assign it to any of the conferences. And it'll also take one conference and send it out to the outside world for you. Next to that is our stage announce connection. Then you have your 4-wire connections there, terminated with RJ45. And your 2-wire connections terminated with 3-pin XLRs. Then we have 2 CrewNet ports. The top one there is CrewNet port number 1, and that's copper only. The bottom one is CrewNet port number 2, which is copper or fiber. Then we have our sync connection next to that, which is copper or fiber connection, and a GPO relay. And then as we move up to the faceplate of the control unit, which looks the same on both models. We have to the left there the XLR jack for your headset for monitoring, comprehensive LCD screen for navigation and control of the system during the gig. And then you've got your USB connections for pairing belt packs as well as for uploading and sending in different types of configuration files. Next slide, please. We have 2 radio transceivers to offer to you. Both of these devices have the radio devices inside of them, a 2.4 gigahertz and a 900 megahertz unit. Next slide, please. On the bottom of the radio transceiver, you can see we have 2 different types of inputs on there and 1 output. Each radio transceiver will support up to 6 belt packs in full duplex. We have a single mode fiber connection in, as well as a copper RJ45. We can loop approximately 7 radio transceivers off of each other in a daisy chain manner, allowing you to have 1 connection to the control unit and have up to 7 radio transceivers on 1 circuit. They can be powered either via the internal power over CrewNet, we like to call it, or a external power supply that's sold separately. Next slide, please. Each radio transceiver has detachable antennas, which enable you to use different types of antennas, directional antennas. You can go to a distribution system, lots of different options there with those detachable antennas. The LED status indicators give you a comprehensive way to take a peek inside of the unit under the hood and see what's happening and see what's functioning. We offer a couple different mounting solutions that are sold with each radio transceiver, and we offer also a dual mounting bracket that you can purchase separately. And each of our devices, like the control unit, this also has a USB input on it for firmware updates down the road. Next slide, please. Now we have a nice view of our radio packs. To the left there is our 2-volume or 2-conference or 2-party line radio pack. And then to the right, we have our 4-volume, 4-conference radio pack. Both of these devices are available as separate models in either a 2.4 gigahertz device or a 900 megahertz device radio pack. Next slide, please. They're nice and light. They're about 13 ounces, about 4.5 inches tall, sound great, 7K audio. Very, very simple to use, as Tom mentioned, very volunteer proof and day hire friendly. Push the buttons on the top to talk, turn the knobs to listen, and you're off to the races and you're doing your job. The system becomes invisible to you. Next slide, please. On the top of the unit, we have, if you look to the bottom right of the slide, there's 2 assignable buttons, and that could be either a call or it could be a trigger for a relay, or also allow you to have access to the stage announce button on the network. Then the triangle button in the center there above the screen is an alternate display button, allows you to dig into the menu and go deeper into the belt pack to do what you need to do to get the job done. You can pull up different profiles, change different settings within the belt pack. Really good way to get in there and get doing what you need to do. As with all of our devices, there's a micro USB for pairing, for charging, and for firmware updates. We have a very nice little clip on the back of this unit that's very durable and have been hanging out very well out there in the real world. Next slide, please. These units operate with our proprietary lithium polymer battery. It's the same as what we offered with Tempest. So if you have any of those Tempest batteries hanging around, those work inside a CrewCom system. And if you get into a bind and you don't have any of those batteries charged, which I know never happens, you always put some AA batteries in here without any kind of a sled or any additional devices needed that you could lose. It go straight in, and you can operate the belt pack with AA batteries. All of our belt packs are also IP65 rated, so they can get rained on and handle adverse conditions. Next slide, please. Now you got to charge these things, so we got a nice drop-in charger, and this is one of the new things that we're going to introduce at NAB, and this is shipping next week. This drop-in charger is what we call a 6+6 drop-in charger. It will handle 6 belt packs and 6 batteries simultaneously. 2 of these chargers will fit into a rack drawer that's 4 spaces high, so you can transport your belt packs and extra batteries inside of a rack if you choose to do so. The batteries will be charged, as we stated on this slide, in about 4 hours from a complete empty. And the LED indicators give you an idea as to what's going on with your batteries. And your belt packs, they go to green when you're fully charged and ready to get back to work. Next slide, please. Our radio packs can be put into our radio charger with our FlexR LR adapter. Art's going to be telling you about that later on, and that's a small little adapter that allows you to use different types of terminated headsets with our belt packs. And once you install that onto a belt pack, you need a tool to get it off of there, a small little greeny screwdriver, something that you commonly have around. But this charger will allow that belt pack to go into the bay with the little FlexLR adapter on there. Charger bottom also has little canals and channels in it to manage cabling, and there's a couple different ways to mount this guy. You can mount it on a wall as it's viewed here, or it could go onto a tabletop or onto a shelf. There's a couple different ways to do it. Next slide, please. Now we get into the hubs that are available for our system. And if you don't want to just go straight into control unit and you need more CrewNet ports, you can use either of the 2 hubs that we have available. We have a copper hub available, and that's what we're looking at right here. The top view is the front panel, and the bottom view is the rear panel. And we put lights on both the front and the back of the unit, so you have the options to mount this with the cables in the back, like all of us audio guys like to do, or you can put it out front like the computer network guys like to do. Whatever's best for your setup. This device can be rack mounted front way or backwards, however you want to do it with any of our rack mounting kits. We have a dual side-by-side rack mount kit, as these are half rack space units, or you can get a single rack mount kit that'll take one of the half rack units and mount it into 1 rack space. You can use up to 4 hubs deep in our network, which we'll be talking about later on. LEDs on the front of this and the back of the unit to give you ideas as to what's happening with the network. And this will supply all 8 devices that are connected to it with power. And port 1 will receive power on the copper hub, so it will run off of POC, power over CrewNet, or it could run from an external power supply, which it ships with. Next slide, please. And we just recently introduced the fiber hub, which is basically the opposite of the copper hub. It has the first port is copper or fiber, and then the following 7 ports are all fiber, duplex, LC, single mode fiber. And as I failed to mention in the previous slide, we can do 10 kilometers with single mode fiber, and we could do 330 feet with the copper. And port 1 is for receives the power, so we can power this unit from power over CrewNet. And that concludes my presentation. Thanks for your attention.
Thanks, Mark. One thing, we did have a couple of questions come up during this. As we went through, you see a number of the devices do have fiber. We supply them with SFPs that are loaded with LC single mode connectors. We support that because we've got to pick something to support that we know works fine. I can tell you that we have many customers who've used different SFPs and had good success. We say we don't support the others. We'll try to help you. We ship what we know works, and but I can tell you that we have had people using everything from multi-mode to single fiber multiplex with good success. But it is a standard load SFP. Okay, I'm going to take over now, and now you've had a chance to see a little bit of the uniqueness of the system, and you understand what the hardware is. I'm going to take you into deployment. Now that we've got it, what do we do with it? Excuse me one second. There is another question regarding Tempest 2.4 and CrewCom 2.4, and we'll take that a little bit later as Tom goes into his RF presentation. Okay, Art, next slide. So we're going to build up a very basic system. This consists of a control unit and one transceiver, and it doesn't matter the frequency, one or the other is fine. And that could be copper or fiber, and that's going to handle up to 6 packs. The next thing we're going to do is add 6 more packs. The only thing we need to do that is we can daisy chain or use the second CrewNet port, and now we have 12 packs running. And now the next thing we're going to do is add a third one. So our capability with a single control unit gives us 18 packs. That is for a single control unit. We can use up to 4. So I could give you 72 packs at either frequency without a problem. In addition to that, we could split frequencies, do some 900, some 2.4, and sync systems. There are many ways to add and go well beyond the 72 limit, and Tom will again talk about that a bit. So the next thing we're going to do is we're going to need another area. So let's go back to a more simple system, a kind of a 6-up throwdown system. So we're going to start with 1 transceiver and 6 users. Okay, and we'll use fiber because it's a long run. It could be copper. It can do 100 meters. And we're going to go into a hub because we want that for distribution because we may need to extend further. And from there, we're going to add 1 more transceiver. Now, the transceivers are identical, whether the transceivers are made for additional users or additional coverage. It's the same piece of hardware, same configuration. And now we have the ability to roam between the 2. Maybe. Can we roam, Art? There we go. Okay, didn't see it on mine, fine. Okay, so the bell packs are going to go back and forth. And now let's add and get a more typical scenario where you have a number of areas that need to get covered. So we're going to add 1 transceiver in the dressing room. We've got 1 on the stage. Okay. And we're going to go ahead and add a second transceiver. And that one is going to be outside in the truck. Maybe it's an OB van that's pulled up or already has it in there. We can connect the 2. One of the unique properties here is this is actually becoming one large system. So that once you connect by fiber, it isn't one system outside, one system inside. It becomes one whole system. And so it doesn't matter what's plugged in where. Any of the ports on the back of either of the control units makes a local connection to anyone on the system. We've installed a hub, and now we're going to go ahead and put a couple of transceivers outside. And so we've got 1 in the hallway, 1 in the truck yard, and now these people can move back and forth any place. So if we didn't need the second control unit, we could use the hub and put all 4 transceivers So just about any kind of deployment that you could think of, fiber, copper, combination of both. If you need IO in multiple areas, if you have multiple buildings, it becomes one bigger system. And that's something that's very different. It's not a standalone quote the way some of the other manufacturers put it, because these are not standalone units. They are units that build up into one larger system. As Mark mentioned, we can do layered hubs, and we can put a hub into a hub into a hub, go 4 layers deep. That can be copper or fiber or both. So for deployment, we really have a lot of different options. As you can tell, we can build up a system. We have, if you notice in this particular drawing, we have 2 volume and 4 volume packs. From an RF level, they're identical. We are the only people who provide 2 different packs, and that's because in many times 4 volumes and too many controls is too much for people, and a significant portion of what we sell are 2 volumes. They're less money, and some people just don't need that capacity. They prefer a simple device. So that's about a bit about how to go about deploying the system. I'm going to let Tom come back in now, and Tom is going to take us through the RF theory, how a lot of the stuff works. And Tom, before we start, let me just look at some questions here. Can 2 CUs be run in parallel, being a live backup? Not exactly. I'll let Tom answer that one. Tom, let me just give you a couple of the questions and we'll go through them. So you want to take that one first?
Sure. In one sense, yes. You could have a control unit that if one control unit goes down, the system will keep operating, but you will lose your wired connectivity. So the real answer is no, not really. But we do have, I'm going to talk a little bit later about our setup up in New York, up at 30 Rock with NBC, and they do have sort of a redundancy built in, and I'll talk about how we do that. But there is some level of redundancy, but no, it's not a full level backup.
Okay. One of the questions that I'll take is about battery life of AA's versus a charge. So the battery life will depend slightly on the frequency. 900 meg is a little bit higher power, so it's a little bit less battery life to it. So it's 8 to 9 hours on average. It takes about 2 hours and 45 minutes to charge batteries to full. The AA's will provide 4 to 5 hours of time. So you have plenty of time to get everybody charged up and running and then flip out the batteries quickly. The next question, Tom, and you can answer this as part of your next session, and I'll log off, is from our friend Kevin Parrish. Hello, Kevin. He wants to know if CrewCom will play with legacy Tempest systems both in 2.4. And I'll turn it to you.
Sure. Yeah, it's a great question. The answer is yes. We do use a different hopping scheme and different frequencies. So they won't operate seamlessly in the sense that I'll talk about it a little bit later, but you can have a number of 2.4 transceivers that we have, and they will literally be completely non-interfering. It won't be that scenario, but you can operate the 2 systems in the same physical space. And because of the nature of the frequency hopping and the way we've done it, they will operate together. So there's no such thing as a free lunch. There will be some interaction, but they will both operate and operate well. Okay, let's go ahead.
Tom, I'm sorry to interrupt you, but I believe this next section, Gary, I believe you're supposed to talk about the RF coverage. Did he leave?
You know what? Let me come back on. We changed the order slightly, so my apologies. I didn't have it on there. So yeah, let me just go through a little bit more. But Tom, you can stay on for this section because it is a lead in. So talking about deployment, just some numbers to keep in mind. We explained that a transceiver can have up to 18 users. I'm sorry, a control unit can have up to 18 users, and a transceiver has 6 users per transceiver. So to have all the 18 users, you need a minimum of 3 transceivers. But the system itself allows you to build up for more units, for roaming, and for more users. So the network capacity of one system, which is whether it's one or 4 control units, so whether you're dealing with 18 or 72 users, these limits stay the same. We can give you a 2.4 gig up to 16 transceivers on the system at the same time. So what that means is if I had 6 2.4 users, I could have 16 different locations of 6 users. If I had 12 users, then I could have up to 8 different locations. But as we'll explain in the RF section, we have the ability to make some special changes there to get very efficient. Now, at the same time, for 900 meg, which is for North America, and we get about half the band for Australia, New Zealand, but in North America, we can have up to 14 900 meg transceivers. So as an example, I know on Monday Night Football, they will typically put up, I think Sunday night sometimes uses 2 or 3, Monday night uses 4 transceivers within a stadium. And then they will put more in the hallways outside by the truck yard and disperse them for a total of about 12 to 15 users. And so you don't have to concentrate. It's a little bit different way of thinking about it, but you don't have to concentrate and put coverage for everybody, every place. And so by a combination of using 2.4 and 900, we can get tremendous coverage and a lot of versatility out of the system. You just have to plan out slightly differently because you do the same thing for roaming or for growing the system to more users, higher density. Next one, Art. Up. Okay, let's keep going.
Next slide. Yep.
Okay. One more. Sorry. There we go. So one of the things that we can do in here, and Tom will get into a little bit more of the specifics, if we have multiple transceivers, we have the ability to manage rights into that transceiver. So I can have people who are going outside. I could have 20 users, but outside by the loading dock, only 5 or 6 of them are allowed to log in. Typically, if you think about this in a stage environment, you have a green room and you have your producer, your director, your A1, your PA, your LD. Those people I have to get to all the time. So they've gone into the green room for a break, everybody's having a cup of coffee, and suddenly all of the cameramen decide to come hang out. Well, those cameramen are not given the rights to log into that one transceiver. So I don't have to try to cover for them at all. I will always have coverage for the people that I specify. So now I'm specifying in that location, the only people that can log in are my ALD, my director, my producer, and the cameramen, even though they're standing outside, never take a slot or a resource away. And Art will take you through how easy that is to set up. Very simple. Okay. All right, and now now we're back over to Tom for RF.
Great, thanks, Gary. So what my goal is to go through this RF section is not to get too deep, but kind of give you an idea of what it is we did to try and overcome some of the challenges that are prevalent in lots of the applications where this product is used. So hold on one second here, sorry. Okay, great. So this next slide shows you the difference between 2.4 and 900. Right now, as I mentioned, we do have 2 radios, a 900 megahertz radio and a 2.4 gigahertz radio. Any given remote transceiver and any given radio pack will either be 900 megahertz or 2.4 gigahertz. They are one or the other. We can use both on the system simultaneously or one or the other, but that hardware is dedicated and it is frequency specific. The network itself is frequency agnostic and we can use either. But as you look at this, each of these 2 bands has some its strengths. And say 900 megahertz has about 1/3 the bandwidth that 2.4 has. So we can get a lot more user density in 2.4. But 900 megahertz, because of the propagation characteristics at that frequency, tends to go further from the remote transceiver to the belt. So you tend to get better range on 900. So it really depends on what you're trying to do, what you're trying to get done. Oftentimes I am asked the question, can you really make a 2.4 gigahertz network work in the kinds of environments that we're working in here? Next slide, please, Art. And my answer is it can be challenging, and there are certainly aspects that you have to do right to make it work, but you absolutely can be successful with 2.4 gigahertz in these environments. And my chief showcase for how you can do that is our installation at 30 Rockefeller Center at NBC. In 30 Rock, we currently have just shy of 400 belts installed up there. Some of those are backups, so I would say on any given day we have something north of 300 belts operating in that facility. Most of those are 2.4. We are operating on 3 floors, so we're on the 3rd floor in 4 studios. We're on the 6th floor in 3 studios, and we're on the 8th floor in 1 studio. All of the 3rd floor and all of the 8th floor are 2.4 gigahertz, and one of the 3 studios in the 9th or the 6th floor is 2.4 gigahertz. So we have somewhere in the neighborhood on any given day of north of 200, 250 belts operating in 2.4 gigahertz in 30 Rock, and somewhere around 100 or so belts in 900 operating there. And
Tom,
that's a challenging. Go ahead.
Yeah, if I may, this is a super critical point because Tom's going to explain about the RF, but very often people just dismiss 2.4 because, oh yeah, it's Wi-Fi, my phone has it, and they're way too dismissive. 2.4 can be an amazing tool for you when you use it properly. And as you can see here, the NBC has no lack of Wi-Fi and 2.4 in their facility. As much as any building could, doesn't matter. It works well when planned properly.
Absolutely, Gary. And as I was going to say, that's maybe one of the most dense 2.4 environments anywhere in the world. It's obviously a location in New York City, but then just with what they have going on there. And we have been able to make it work and work quite effectively. As a matter of fact, I've been up there a number of times supporting the system and doing other things. And I've talked to a lot of the users, and they really have no idea the frequency band that they're operating on. Some of them are operating on 900, some 2.4, some switch back and forth, but it just works. And that's what's important, and that's what we're trying to do here. So as we go forward, the foundation or the foundational scheme, I'm just going to kind of go over the mechanisms that we use for this. We use a frequency hopping spread spectrum. Obviously, the way we get multiple users on the same frequency at the same time is TDMA, time domain multiple access. And then we use a Gaussian frequency shift keying, which is just a relatively rudimentary form of modulation, but it's extremely robust and it just works very well. Then we use a multiple simultaneous carrier system. This is almost like I like to call it a poor man's OFDM. It's an OFDM-like proprietary scheme that we use, and I'll go over why that's important here in a little bit. We also use lost packet concealment. Everybody does for the most part because all wireless systems end up losing data. That's just the way it works. But we use a very advanced lost packet concealment algorithm that really works well to hide the data that you've lost and smooth out the audio and make it sound more natural and less robotic and those kinds of things. Those of you that have used Tempest in the past, when you go to CrewCom, you will notice a marked improvement. Not only is the bandwidth about double, but also just the audio quality and the lack of digital sound and those kinds of things. And then we also use what we call a 2xTX. It's a redundant data transmission system. And what we do is we actually send all the audio data multiple times, 2 different times. And I'll explain how that works in more detail, but that makes for a very robust type operation. We also do that out of multiple antennas in both the remote transceiver as well as the belt. Again, I'll show you that here in a moment. And so all of this adds up. We have spatial diversity because we're operating out of multiple antennas. We have polarization diversity if you set the antennas up correctly and have them at right angles to each other. We have frequency diversity because we're hopping between the times that we send the data. And we also have time diversity. Each of the transmissions is separated by about 10 milliseconds. When you add all of that up together, you make for a system that really does a great job of overcoming interference, really in very hostile RF environments. So let's take a look at how this redundant data transmission works. So we obviously convert the audio into digital form, and then we send it out on the first antenna on this first frequency. Then we send that same information out on a different frequency 10 milliseconds later out of a different antenna. So you've got lots of different propagation characteristics that are going on in any given space. And we're going to take advantage of the fact that those things are very spatially dependent, frequency dependent, and time dependent. And we're going to allow these different forms of diversity to help us get one of those two transmissions through. So if one of the transmissions doesn't get through, the statistical probability that the other one will get through is high. So then we're going to take the next audio packet, the next 20 milliseconds of audio, and we're going to send it on a different frequency out of that first antenna again. And then we're going to resend it out of the second antenna on a fourth frequency. And this goes on for each audio packet that we send. Our audio packets are about 20 milliseconds, and we send them in 10 millisecond increments twice. And that gives us the ability to really be very robust in very difficult RF environments. But we also use two antennas in the belt as well. And what we do there is when we send the transmission out of the remote transceiver, we monitor both of the antennas in the belts. We look at the beacon from that transmission coming from the remote transceiver, and we decide which antenna in the belt is receiving that beacon better at that particular frequency at that particular moment in time. And then we use that particular antenna for that transmission cycle. And that happens each time we send data. And that helps us overcome if you're blocking with your body, if you're bending over, if the polarization is happening in certain ways, if there are reflections. This technique really helps us optimize the RF path as we go through. So let's talk about frequency hopping spread spectrum for just a moment. It's fairly common. I think people are most familiar with what it is. But what it allows us to do is operate multiple systems at the same time. Kevin earlier asked if 2.4 Tempest and 2.4 CrewCom could operate simultaneously, and they can, primarily because of the frequency hopping nature of what we're doing. We do hop 100 times a second, so every 10 milliseconds. And it really does help to minimize the effect of outside interference sources like Wi-Fi, like camera shaders, like other things that are going to be happening in the environments that you're operating in. So we have this next slide that just kind of shows you a visual representation of how frequency hopping works. But then here, what it's also going to show you, just wait for it to catch up to me. If there's an interference source, even a very difficult interference source in part of the RF spectrum, as the device is hopping from frequency to frequency, and as we're doing that, and as we're double sending the data in different areas of the spectrum, you have a good chance of having at least one of your transmissions be outside of that interference section. And that really is the power of frequency hopping. Combined with our technique of double sending that data. If we take a look at Wi-Fi channels, you guys are all very familiar with this. You have 13 or 14, depending on where you are in the world, 11 to 14, depending on where you are in the world. But really 1, 6, and 11 are the ones that are the most commonly used everywhere. And if you look at that, they take up the vast majority of the spectrum. So this next slide shows you sort of the difference of what a CrewCom signal might look like versus a Wi-Fi signal. Wi-Fi is very spread out. It tends to be about the same amount of power as our system is, but that power is spread out. So the average amount of power across the area that we're hopping is much less than our particular peak power in a very narrow type environment. So what ends up happening is the Wi-Fi channel looks like background noise to us, and we look like a very narrow interference source did, which it has redundancy factors for. And so we work very well together. We work in a lot of stadiums where there is a lot of fan experience happening in both the 5 gig and the 2.4 areas. And we have a lot of equipment working there. The Wi-Fi works well in conjunction with us, and we work well in conjunction with the Wi-Fi. And again, this slide shows you how most of that area is taken up, but the difference in the way the signals are created and the primary characteristics of each of those systems or each of those signals help the systems work well together. So multipath or relay fading, you may have heard it called, is very frequency dependent, location dependent, and time dependent. For those who are interested in the math, that's what it looks like. But by changing frequencies over time and by sending the data redundantly, we can use the characteristics of frequency hopping spread spectrum to really overcome multipath for the most part. Relay fading or multipath happens when you get signals that are out of phase that arrive at the same time and cancel each other out. Multipath does a great, or frequency hopping spread spectrum does a great job of overcoming multipath. But it doesn't fix everything. One of the things that's a really big problem in all digital communication systems is intersymbol interference. This is really the big problem. Most of the manufacturers out there do things that mitigate multipath reasonably well. This is the one that really gets to be a problem. If you've ever tried to use some wireless digital systems, including Tempest 2.4, in domed stadiums, you know that it's a very challenging environment for those kinds of applications. And so what happens is it's not about the frequency that you're operating in. It's really about the symbol width that you're operating. So I'll show you kind of what multipath looks like. We get this direct path, we get this reflected path. But really what it's about with intersymbol interference is not the phase relationship, it's about the time relationship. So as we do that, if the two signals arrive enough out of time with each other, then the receiver can no longer differentiate whether that bit was a 1 or a 0. And that's where the problem comes in. So if we go to this next slide, we can kind of take a look at this. Most of the systems out there, whether they be DECT or Tempest 2.4 or even other types, use a symbol width that's very similar to what you're seeing here. It's about about a microsecond long. And so this bit takes a certain period of time. In this case, it's about a microsecond. When the reflected signal comes in, depending on how much it's delayed, how far it had to go in the reflection path, it causes an area of distortion that the receiver can no longer tell whether that portion is a 1 or a 0. And if that area of distortion is enough of a percentage of the total bit, the system falls to its knees. Some of you have probably experienced using a digital system in these environments and not being able to get 30 feet on a system that you would normally be able to go 400 or 500 feet on. And this is the situation. This is the problem. Well, we've taken a unique approach, I think, to solving this problem is we use longer bit widths, longer symbol widths. And so it's about 3 times or so longer. And when the delay comes in the same amount delayed as the other signals, because that's environment dependent, not RF dependent or not signal dependent. And so you still have that same amount of distortion, but it represents a much smaller percentage of the bit. And because of the way receivers are designed, the receiver can still determine whether that bit is a 1 or a 0. And so it's like the intersymbol interference isn't happening at all because the receiver doesn't see it. So as we take a look at this next slide, you can see that these bits in traditional DECT systems or others are much narrower than what we use, about 3 times narrower than what we use here in CrewCom. And so we end up getting a device that's very actively usable in very large environments. So say a dome stadium or an airplane hangar or something like that. We really thrive in those environments because of the way we've handled this intersymbol interference. But those of you who are savvy with data transmission schemes might be asking right now, if you're using a longer bit width, that means you have to be sending less data. How do you get enough data to do what you're doing? And what we've done is we've used this sort of proprietary subcarrier, almost an OFDM-like scheme, to take and put carriers together that are each of the carrier has a longer symbol width, but they're operating together to get the data that we really need. So all that gets us the data we need to get high quality audio from one place to the next, but it still allows us to not suffer the effects of intersymbol interference, like a lot of other digital intercoms do. The next thing I just want to touch on briefly is adjacent channel rejection. This is really just, by definition, how good is your front end, how linear is your receive signal path. And in most systems out there, you get about a 30 dB or so adjacent channel rejection. In Tempest, we really did a pretty good job of designing that, and we ended up getting something close to 50 dB of adjacent channel rejection, although that was not the case 1 channel away. That was actually 3 channels away. But we were able to get a reasonable amount of adjacent channel rejection. With both CrewCom 2.4 and 900, we're getting 60 dB 1 channel away. So over 10 dB better than Tempest 3 channels away, and as much as 20 or 30 or 40 dB better than a lot of other systems. What that does is help eliminate the interference problems that we see in very crowded environments like sporting events and things like that. Gary, did you have some questions?
Yeah, a couple of things to clarify. One question was, do we use the same anti-multipath technique for 2.4?
Yes, it's a great question. The things that we do for 900 and 2.4 are identical because they have to do with the symbol width and the multipath rather than the frequency dependency of that. So they are the same.
Okay, and the other thing, if you could take a minute to discuss, I talked about system deployment, but the culmination of many of the things that we're doing here, the ACR, the frequency hopping, really allow for very easy deployment because we don't really have to worry much about antenna location, especially if we're putting up multiple antennas compared to other systems.
Yeah, that's a great point, Gary. One of the things that Gary's pushing at here is you could take, let's use 900 megahertz just for an example. We have 14 different hopping frequencies in 900 megahertz. So you could literally take 14 of our remote transceivers and gaff tape them together and lay them on a table, and they would work without interfering with each other. So what that means is you very rarely need 14 all in one place, but what it means is that you can deploy those wherever you need RF coverage without worrying about them interfering with each other. With DECT, you have a relatively limited number of carriers, and so you really have to be very diligent about how close or how far your transceivers are located because they can interfere with each other in that regard. With our system, it's really more of a throwdown approach. If you need coverage in an area, you put a transceiver there, and you really don't have to worry about the interaction.
I think this gets back to something I said in the very beginning, which is we're trying to make this easy for people. We have quite a lot of attendees in here who truly are RF experts, but there is so much RF going on. If there's one area where you just really don't have to worry, it makes your life easier. And so for the simple installation, for the easy rental, for the dry hire, it's a dream because you don't have to have any expertise. And for the guys who need to put together a big system, and you know, we've got quite a number of companies who do this on a regular basis mobile, they just put it up and go, and they can spend their time worrying about the stuff that's real challenges like IFB and you know, radio mics and everything else that really are problematic and difficult. So again, you know, this really, all of this technology comes down to reliability and simplicity.
That's a great point, Gary. One of the things we wanted to do is make sure that you could take just a throwdown system, a control unit, a radio transceiver, and 6 belts, and just flop it down and be ready to go right out of the box. And we can do that with this gear. But because of the technology we put into it, you can scale from that to 400 belts and 30 rock using exactly the same equipment.
Okay. I have a question from somebody, and they'd like to know if we've done any adjacent channel comparisons to any of the other systems.
Well, that chart that, Art, if you back up one slide, that chart is an attempt to do that. Yes, we have looked at individual other products and what their radio adjacent channel rejection is, and this is essentially a representation of that. One channel away, DECT as a radio source is dependent on how you implement it, but typically what the DECT radios, consumer products aren't quite this good, but most of the products that we're dealing with in our industry have somewhere between 15 and 20 dB of adjacent channel rejection, one channel away, and something like 30 or so, 2 channels away. And that's what this chart is showing.
And one other thing to clarify about DECT is not a frequency hopping system in the way ours is.
That's right. That's right. And so they tend to co-occupy next to each other longer than we do, whereas we're kind of hopping around. But Gary, I think some of those may be answered in this next slide. These RF takeaways. I'm not going to go through each one of these individually for sake of time, but you do have them in your handouts. But essentially, the comparisons that we're making here are to show you how we've designed a system using proprietary RF rather than off-the-shelf RF, because we were able to tailor it to work better in really hostile environments. So large venues, reflective areas, very crowded environments, all these different factors play a role. And so as we get down to how do you implement this to be successful, you can really do it the same whether you're doing just a few users in a church or whether you're doing 18 or 50 users in a stadium on a football Saturday or Sunday. And I think that's pretty much it for my section. I think Art is going through the rest of those slides. I kind of skimmed over them, but I think the next thing we're going to have is a discussion about CrewWare, and I believe Art is going to take us through that.
That is correct. And Gary, did you have a question? Did a question come up?
Actually, I think we've answered that. We do need your camera up.
Actually, since I'm going to be doing software, at least for the first part, I will just switch over to CrewWare. Okay.
All right. So Art is going to take us into CrewWare. CrewWare is our application for configuration, monitoring, and real-time control. There will be a link from the website for you that will enable you to download and do a large portion of what Art is doing if you'd like to get to know the software. I'm going to sign off and put it over to Art.
Yeah. Actually, just Gary, can you verify that you're seeing the PowerPoints on CrewWare?
Yes, it looks good.
We got it.
Okay, cool. Just want to make sure, because I forgot I do have a couple of slides. I did want to go over just kind of a basic overview of what I'm going to be covering. We're going to talk about CrewWare. And by the way, the CrewWare, and I think I've mentioned it somewhere in the PowerPoint slide, this is a free download, and we will supply you with the link. It's actually in the handout for CrewWare. But basically, CrewWare is how you build your system and how you monitor your system. There's an offline mode, there's an online mode, of which both of them I'm going to show you, but just briefly to kind of give you an idea of what it's all about. Essentially, it's a standalone application. that allows you to essentially build your system by dragging and dropping elements onto the grid, and I'll show you how to do that specifically. You'll create all your conferences, you'll create all your profiles, all your port assignments, basically setting up what we call your system configuration or your system configuration file. Sometimes we refer to it as a CCF because that's the file designation that it goes by. But that's pretty much everything you do offline in creating a system. And then once you've got your system deployed, all up and running and everything, you got your system configuration file on your system, then you can go in what's called live mode, and I will briefly show you that as well. And that will allow you to essentially monitor your system and do some live changes as well on individual devices while you're actually running the system live. There also will be some system diagnostics that are involved in that. So just to also give you just a quick overview, we have had several mentions of profiles, but just as a quick review, a profile really determines how the radio pack is going to operate. And this is all going to be set up in your software. And then you create that, make that part of your configuration file, and then you upload it to the packs. And that can be done either pushed over the air, what we call pushing, or we can pull it from the pack. And we'll talk a little bit more about that, but essentially what I'm going to be showing you is how to create a profile. And then once we go live, I'll actually show you how to push a profile out to the pack. The profiles are pretty important to the system. Now, the profile also basically creates a personalized operation experience for either an individual pack or a group of packs. It really depends on how you like to operate, but you can do it either way. You can have a profile for every pack, or you could have a profile for a group of people. Let's say spotlight operators, for instance. You could have multiple guys using the same pack, the same profile on all their packs. So it can be done by job type or individual user. But this is essentially where you're going to set up all the customizations for communications. And once again, I'll step you through that. I'm not going to go through this whole list, but this kind of gives you an idea between the way we break down the profile. We have global settings, which include profile name, conference assignments, ISO, all these different settings for the individual, either the individual pack or group of packs. And then we have user settings, and user settings are actually separate from the global settings, so that if, let's say, go back to my spotlight example, where you have one profile for multiple packs, let's say you need to change the mic gain on an individual pack, you can still do that. Okay, so that's just kind of letting you know how those differ from each other. As I mentioned, once you create your system, you're going to basically save it as a what's called a system configuration file, a CCF, and that allows you to essentially, you can build it on a plane on the way to an event and deploy it. If you need to change events, you can basically save it and deploy it very easily. You create it, store it, and recall it into the system. And there's different ways to do that. You can either bring it into the front panel of the control unit through a thumb drive, or you can upload it through the network into your control unit, which basically actually it would be your master control unit if you have multiple control units. But part of the managing of the profile is to administer the roaming area access, which both Tom and Gary have both explained, but I'll actually go into that to show you how to do it. And the other part of the configuration file is the actual device setup and also the topography, how you're going to lay out, whether you're going to use copper, you're going to use fiber, all the different devices and so forth. And that's, once again, very easy to set up, but that's really kind of the first thing you do, and I will step you through that. So let's go ahead and we will switch over to CrewWare. Are we seeing CrewWare on the screen? Somebody confirm?
Yes, it's good.
Okay, great. Just want to make sure. So when you bring up the software, this is essentially what you'll see. It'll come up to a blank screen. There won't be anything on it, but over on the left, you have several tabs. On the left bottom, you have a system diagram tab, conferences, profiles, and what we're going to be using is device toolbar. You'll see in the top left that we are currently offline, so that's the way we want to be when we're building a system. As is mentioned earlier, every system has to have at least one control unit. So we're going to basically just drag one control unit out to our desktop here, onto our grid. And then over here on the left, one thing I didn't mention within the toolbox, and this is a relatively new feature in the last version that came out, you can customize your toolbox. So let's say you're not using any 2.4 gear, or you're not using any 900 Oceania versions or Australia, New Zealand versions. you basically can hide all the devices that you don't normally use and put those into your My Toolbox. In this case, I'm actually going to pick some 900 N24 so you can see how you can put them on the same system. But once again, one control unit is all that's necessary, at least one. Then you can decide, in our case, we're going to use a copper hub. So I'll just drag a hub out. And very simply, when you want to make a connection, you draw from one to the other. I will point out, let me hide my little screen here. I'm going to zoom in so you can see better. As you can see here, there's two different types of connectors. And when Mark did his presentation, you saw on the back of the control unit, there was an RJ45 for the CrewNet connection number 1, but CrewNet connection number 2 is actually an either or. It's a fiber or copper. By default, when I made the drawing, it made a copper connection. However, if I right click on it, I can change that to a fiber connection. So in our case, we're going to have our hub pretty far away. So we're going to run the hub over there via fiber connection. The other thing we're going to require are some transceivers or RTs. I'm going to throw a couple of 900s out there. So you just, once again, you can drag them out. Just like anything, there's multiple ways to do things. You can copy and paste transceivers if you want to. I just like just dragging them out. It's quicker for me. But we're going to put multiple frequencies. So we're going to have 900 and 24. As you can see, there's little warning symbols there. That's just telling me that I haven't connected anything yet. Let's throw out another 900 RT just to be safe. So the next thing I need to do is I need to connect these transceivers. So what I'm going to do is I'm going to come out of my hub and I'm going to go to my first transceiver. And by the way, I can make little adjustments if you want to change the lines and so forth. That's pretty easy to do. Move things around as you want them, make things look nice. That's all definitely capable of doing that. In this case, I'm going to go out to an area where I'm going to need, let's say, 18 people. Let's say this is the arena. And now what I can do is essentially start daisy chaining those together. So now all those RTs are in one location. And you'll see, I'll be able to go back and label these as well. Right now, we're just doing a basic layout of the system. This is typically the first thing you do. You don't have to go in this order, but this just happens to be the workflow I use. But typically, you're going to lay out all your hardware first, but you don't have to do it that way. You can do conferences or profiles, whatever. It's all up to you. So now I'm going to make a home run back to the hub. And once again, this is a copper hub, so I can go copper to there. Let's say I needed to run some fiber out to another location. I can quite simply go onto that, make a connection there, and now I can throw some more RTs out there, and I can do fiber connections. It's all just drag and drop, and you can see the difference in the fiber connection automatically puts the different color on there for the fiber connection. So let's say, well, one thing we've actually emphasized there in our presentation is the ability to put multiple control units. And as was mentioned, you may need multiple control units depending on the number of users you have. So if you need to go beyond 18, you'll go to a second control unit. Or let's just say you need more I/O. You can add another control unit. And quite simply, you just drag it out there and then we'll make a connection. And it can be anywhere. It doesn't have to be connected between directly to the CU. It could come off of a hub, but that CU can now be placed anywhere it needs to be placed. You needed the I/O out in the truck yard and everything else could be in the arena. You can have the CUs in 2 separate locations. Now you've got that I/O.
Art, if I just to reinforce something, Art just said those can be placed anywhere, but regardless of where they are still part of one bigger system that's twice as big as this system with a single. So it doesn't matter the location, and it isn't 2 separate systems. It's one bigger one. We just happen to be spreading the resources into different locations.
Yeah, good point. Good point. Okay, so let's say I'm done drawing out my system. I'm actually going to hide that so it gives me a little more room. What I typically do next is I create all my conferences because you're going to need your conferences to assign your I/O and do a couple other things, assign your buttons and so forth on your profile. So I usually go to conferences next. I'm going to keep it simple and I'm just going to create 2 conferences. All I did was simply hit add conference twice. And now it adds 2 different conferences, conference 1, conference 2. Those are just the defaults that pop up. But let's say I want to do audio and lighting. And I just simply type it in. And now I've got audio and lighting as my conferences. Let's say I want to make sure that I can do an ISO on the audio conference. This goes back to earlier in the presentation when we talked about setting up ISO. The first thing you have to do to set up an ISO is make that conference enabled to handle an ISO. In this case, we're just going to do it on the audio conference. We're not going to do it on the lights. Okay, so now we've got our conferences. Also mentioned, as was earlier stated, you can have up to 64 conferences currently. So you just can basically sit here and add conference for however many conferences you need. Pretty simple to set up. Okay, the next thing I usually do is I usually go back to my device and look at my CU, because now I'm going to assign those conferences to my two CUs. I essentially have all my 2-wire ports set up, my 4-wire port set up on both of my control units. You can also name your devices here. Don't have to do that. It's completely up to you. And let's see, we're making this one a secondary.
Yeah. Art, just one point. You know, we refer to conferences, but practically speaking, they are the communication equivalent of a party line. If you had a party line with just 2 people on it, it's a point-to-point. With many people on it, it's a party line or a conference.
Yep, good point. So let's say in my case, I'm just going to use 4-wire connections. So I simply come over and assign conferences. So I've got audio coming into 4-wire 5 and lights on 4-wire 6. And I select turn it on, even though it's called type, it's just an off and on. Over on the 2-wire side, let's go ahead and on my second CU, I'm going to use a couple of 2 wires. I'm going to use 3 and 4 just to be different. And we're going to assign the same 2 conferences to a 2-wire port. Once again, as Mark mentioned, these are all working simultaneously. So I can have all this IO going at the same time. Then I select what type of, what format. Okay, it's telling me, give me a warning, even though I'm not live, that I could have an issue because I'm changing the type of 2-wire connections. Just a little bit of a warning in case I was in live mode. So anyhow, that's made all of my assignments on my control units. That's usually what I do next. And then I come.
Just a quick thing here. The way Art has this set up right now, where a 4-wire port and a 2-wire port are both assigned to a same conference, essentially you would have a 2-wire to 4-wire converter that you could use if you had, say, 2 4-wire ports connected to the same conference. You could actually transport that audio into different locations. So it's kind of a unique way of doing things that we allow you to do.
Great, thanks, Tom. So after I do my IO assignment, what I typically like to do is go back to my system diagram. And I'm not going to do it here for time's sake, but I would go and label all of my transceivers. So I'm just going to label a couple of them just so you can see what they look like when we get to that point. But you can label them different ways. This is in device view, and I can just go from one device to the next, arena 2, and so on and so forth. I can go back to my list view, and that's another way to do it. And it shows me all of my transceivers, and I would go through and I would label all of my transceivers. And then if I wanted to, I can delve back in deeper and double click on it, and it goes back to the mode where now I'm looking at just that particular transceiver. Now, while I'm in here, I will show you a couple of things that are kind of interesting. This is where you can make changes to radio band, to the hopping pattern, the transmit power, and also antenna diversity. So for instance, with radio band, if you need to, we can do full band means it hops across the entire 902 to 928 spectrum. High means we basically cut the band in half and you're only using the high part of the band, and low is the low part of the band, and mixed means that we can mix high and low on the same system, which for some of you out there that are current users, you're probably thinking, hey, that mine doesn't have mixed on it. That's because this is version 1.8, which is coming out next week, will be released next week. So you will see some things in here that are new. That's one of them. Just to also note, you are able to determine, it will automatically assign a hopping pattern And this goes back to Tom's explanation about frequency hopping spread spectrum. Each transceiver has its own hopping pattern. So you can assign hopping patterns manually, but it will automatically, as you saw me drag them out into the grid, it automatically assigns a hopping pattern. If I go back to my list view, you'll see all the hopping patterns, but you can actually change those manually if you're coordinating either multiple systems or you're doing some things where you need to expand system capabilities. Then again, you also have transmit power. You can basically pad down the antennas if you need to. This is all for managing special instances of covering certain areas with different high RF environments and so forth. You can also, dual antenna does what Tom was talking about, where it transmits out of the left and then transmits out of the right. You do a double send. But you can only use, if you wanted to, for specific applications. Let's say you wanted to use a Yagi antenna, you can go with just one Yagi antenna for a 900 meg system. And then you can just use the right antenna or the left antenna, depending on what you want to use. Or you could have transmit on the left antenna and receive on the right antenna. An example of that would be if you had an existing RF distribution system, you can set it up for transmit on the left, receive on the right. So some really detailed things there in terms of the transceiver. So we've got our transceivers, a couple of them labeled. Like I said, I would typically label all of them. So now let's go and we're going to create a profile. And this is very easy to do. You simply, just like you did with conferences, you hit add profile. And just a little bit of a tip here. And the way I typically like to work, which is easy, you notice I didn't hit add profile 4 times, let's say, for 4 different packs. The reason being is it's easier to create a base profile and then clone that profile. It makes it a lot easier, and I'll show you why. There's one little thing you got to remember. You notice when I created this profile, the model here says CRP 44-2400. That's a 2.4 belt pack. If you're, let's say you're doing 900 only, you would have to go in and change that. So what I typically do is I double clicked on it, and now I open it up, and I'm going to name it my name. I'm going to go the route of each person has their own profile. So that's me. And I've assigned a profile name, a long name, and a short name. The long name is typically used for all the software, and the short name is usually used on the devices, like on the pack, for instance, or on the front of a control unit. So that's the reason for the long name and the short name. So now I have this one profile that I'm going to change to 900. So it's a 4-volume 900 pack. You notice the transceivers changed over here in this scan list. This is the scan list that Gary and Tom talked about, where you can basically select where I'm going to have access to. So let's say I don't need access to these other areas here, and I only need access to the arena. So what I did is I simply just eliminated access to those 2 other areas, thereby just giving me access to arena and arena 2. Now the other thing I can do is I haven't done a group yet, which I'll have to show you in just a second. This is a new function. We'll have to come back and show you that. The main part is now I have to assign my conferences to a button. So this is a 4-channel belt. So I've got 4 buttons. Unfortunately, I only have 2 conferences. So what I'm going to do is I'm going to assign them button A, and I'm going to make that switch momentary, and then lights, and I'm going to make that one latching. So here's my options. I can disable that button altogether. Let's say it's a program channel. There's nobody really talks on that channel. I can disable that button. I can make it momentary, latching, or always on, depending on how I want to do it. In this case, I want to do latching. To set up that ISO we were talking about, we already put ISO on the audio conference, so I'm going to enable this particular belt pack, my belt pack, the ability to talk on that ISO channel. So let's say I needed to talk to Tom on an ISO channel. I would go and create a profile for him and check his box. So now the both of us can now ISO with each other, have a private conversation on top of that audio conference. So that goes back to the whole ISO explanation that we talked about a while ago. And then we have the 2 function buttons that are on left and right side of the top of the display. And it defaults to stage announce, but I can turn that off. And I can do any number of other things. I can create a call function. I can assign a relay, which we haven't set up relay, so it's grayed out here. But let's say I want to set up a call function. And I can do call on active talk, which basically will send a call signal out of whatever button has a has the talk button pressed. And then I would have to press the function button to send that call. In my case, I just want to have an audio conference call button. So now whenever I hit that function button, it'll send a call signal to everybody on the audio conference. It will send it out both the hardwire and the wireless channel or wireless portion of that particular conference. And then I've got all my user level settings. We talked about mic gains, noise gates, et cetera, et cetera, et cetera. So I've created my profile. Now, okay, now I need more than one profile. So I just clone profiles. And now I've just created 4 900 meg profiles. And I could do the same thing, set up a 2.4 profile, clone it, rename names, make different button assignments and so forth. And then you can go from there. Now, one of the new features we've added is something called a group. And a group will allow you to group multiple users, let's say in this case into an audio group, into a lighting group, you could have a production group, whatever. And I'm going to create 2 groups. And what I'm doing is creating a group for grouping profiles. So I'm going to have an audio group and a lighting group. And I will, of course, change the color so they will look a little bit different. Changing the actual background color and the font color. So now I have 2 groups. So now when I go back to my profile, I can assign myself to the audio group. I'll assign the next person to the lighting group and the next person to the audio group and so on and so forth. And those all go assigned to the profile. So now I've got my devices all set up. I got my conferences all set up, my profile and my group management. The next thing I would do is I would save this. So I would come over and just save the file and it'll save it as a CCF. And then if I've got my hardware all deployed, all ready to go, I would get on the network, or I can use a USB thumb drive, as I mentioned earlier, and I would connect to the control, I would upload the file. And upload file will actually take the configuration that I just created and load it up to the master control unit. And just so you know, if you have a multiple control unit system, the configuration is only stored on the master. There's none stored on any of the secondary control units. So each control unit stores 1 configuration file. Okay, so that's done all of my offline creation. I'm going to close that out.
Actually, Art, before you go past that, one more thing I want to point out. Let's go back to the profile management for a moment.
Okay.
Okay, so philosophically, everybody has a different way to work. So Art had mentioned that he was going to 1 person, 1 profile. So you can make an individual profile for each person, or you can make a profile that many people will share. For example, spotlight operator. You have 7 spotlight operators, they will have the identical profile. Or you have camera operators and they can be identical. So depending on your style of operation and what you need for your application, you can go in either direction. You can have it by job function or by individual.
Yep.
And there are plus and minuses to both ways of working. WWE has a profile for every single person individually, but NBC does groupings of profiles. It really is a matter of how you want to work, how you want to update the profiles, and how much customization you want for each person. But we give you the power to do either way.
Great. Great example, Tom. Okay, so now we've got our system basically created, our configuration file, and we've uploaded it to our system. And what I will do is I'm actually going to close out. I'm not going to save it. And I'm going to turn on a couple of my packs, which I forgot to turn on, just so you can see it. And then I am going to go into live. Over here on the top right, you can see my cursor, my arrow, and it says not connected offline. So if I come over and click on that, it's going to ask for a device. What it's looking for is the IP address of my control unit. It happens to be sitting at this IP address. So I click OK. And what it's doing is basically getting onto my network and dialing in. And now it's looking at my system live. Obviously, I don't have that big system that I drew out, but I do have 1 control unit and I have 2 transceivers. And what I'll do is zoom in a little bit so you can see it better. But this is an actual view of my system. So now we're looking live and you'll see a few things here. This is actually new down here, and these are inactive packs. And this is telling me, we didn't talk anything about pairing yet, but when you put together a system, you do have to pair each pack to the control unit. So what this is showing here, that I have 3 packs that have been paired to my control unit, but I don't have them on. So that's just kind of letting me know that some packs haven't logged in yet, even though they're paired to the system. It also keeps track of all the packs that are paired to that particular control unit. So I'm going to kind of hide that part. Don't really need to look at that. But what we're looking at here in this section, what we affectionately call the radio pack farm. And the way I have it set up right now is it's showing the packs. And by the way, I did this on purpose so you could see what it looks like when a battery is running low. There's 2 different statuses you're seeing here. This is showing my pack number 2, which is Mark's profile, and he's logged into the RT called house. You'll see that his battery is low. And you'll see it in a couple of different ways. You see the flashing low, which is what you would see on the display of his pack. You see a red around the box, around the icon, and you also see a red up here at the top showing me that his pack is logged into the house RT, and then I can at a glance see that, hey, one of my RTs that's logged into house, he's got a low battery. So that's a really good way to see all of the different statuses of the pack. So the way I'm viewing it here, though, is I'm looking at my backstage packs are showing in this row, and my house packs are showing in this row. There's a couple of other ways to do it. If I right-click on that, we're using the new organize by function. I can now use my groups. So if I go to group and ascending, now you see the groups that I've created. And in this case, I've created, let's see, audio, lighting, production, and rigging as different groups. So now you can see that they're grouped by the different groups that I created. So if I go to my group management tab, you'll see all my groups listed here. So now I have the ability to show those packs in groups, even though they have different profiles. So let's see here. The other thing I can do is to have different views. If you have a lot of packs, this is a good way to look at packs. You have an icon view. I can go from either the icon view or the tile view, and if I double click on any of these packs, let's show my system diagram, but if I double click on this pack, it shows me that pack live. Now, one of the things you'll notice here, and this has taken me a little bit of getting used to, you'll notice it's grayed out. That's because we have a new function called access rights. I have my software locked. You can now lock your software or lock the hardware using something called user rights, which is set over here, user access rights. I won't go into that in detail, but I need to unlock my software with the super secret 1111 password. So now I have the ability to go in and change things. So now if I need to go into Gary's pack and I need to change his mic gain, it's a little bit hot, turn it down, turn up his side tone a little bit, I can make changes on the fly. This is all happening live. So since we're in live, we're making these changes in real time. You'll notice when I change something that you get a green dot, and that's telling me that I've basically strayed away from the profile. So this means it's different than what my profile is set at. If I need to revert back, I can just click on those dots, it'll quickly get me back to where I need to go, or I can hit the restore button. So
Art?
speaking of, yeah.
Hi, we've got a question or two that might be a good time to take.
Okay.
Okay. Can we minimize any of the screens so you don't want to see the alerts, for example?
Yes. Any of these little triangles here can collapse. So I can take any of those screens and minimize them. Does that answer the question?
I think that answers the question. And one question about the party lines, that yes, we do have 64 party lines, the equivalent of 64 PLs that are available all the time. There's a question about how that works. There's also a question regarding Mac and PC. And one of the things here is that it's currently PC only. We do have a long range plan for Mac. We do have people who've run it over parallels, although I'm not a Mac expert. And one of the important things about CrewWare is that it's an application. It's not HTML based. And that's very specifically because we don't have to try to chase the browser wars as HTML evolves and different manufacturers are doing different things. So when we can save something, it's a very simple process. and gives us much more control over the system. Okay, I'll let it, Art, I think we've got a little bit more to go with Peter, but I'll let you go back to finishing.
Okay, yeah, I'll pretty much just wrap it up. The only other thing that I really wanted to show, which I'm going to turn my camera on for, is I'm going to show how to send out a profile or change the assigned profile. And got my camera?
Got it.
In my pack? Okay, great. What I'm going to do is, you see here under Gary's pack, once again, this is his profile for Gary. Well, actually, this is Gary's pack in live mode here. You're seeing his RSSI, his link quality, all of the different buttons. If I were to push a talk button, you would see that change. You see all the functions change. Let's say I needed to assign him, this is not a good example because he's a 2 volume. Let me go to a 4 volume. I'm going to go to Marks. This is RP number 2. So what I will do is I need to change his profile. Let's say I need to give him a different profile. Let's say we weren't doing the per person per profile idea, and I needed to give him a different profile, let's say a lighting profile for the lighting group. I'm going to send out Tom's profile to him. So when I change profiles, you see it asks me a couple of things. Are you sure you want to send that profile? Because what happens when you send a profile for about 2 or 3 seconds, as you'll see on the display, it will actually upload that profile to the pack. And the other thing, it asks me if I want to change those user level settings that we were talking about. So if I made some mic gain changes or something like that, I don't want to overwrite those. So typically I don't check that checkbox. So anyhow, if I click yes, what happens is you see this on the screen, it updates it and it's done. So I've basically changed the entire functionality of this belt pack by uploading that profile over the air to that pack. To give a good example of where this really came into play for me personally, is I was doing a show, an award show, and we had a rigger come down with his pack, and he had the belt clip in one hand. This was a demo, by the way. He had a belt clip in one hand and the pack in the other hand. He said, "Oh, I'm so sorry. I got it caught on the catwalk upstairs, and it ripped the belt pack or the belt clip off the pack." Luckily, we had a spare. We had profiles for every name, so I just asked him his name. And then I was able to go into the menu, because you can do the same thing. You can pull it in off the pack. Since I didn't have access to the software, someone else was running the software, I was able to pull in off the pack his name. I just dialed up his name and then handed him the new pack, and off he was running. So a very quick way to handle changing profiles.
All right, so you could push the profile from the system or pull it directly from the pack as long as you've got admin rights.
That's correct. Yeah, that's a great point. In the latest software, you do have to have admin rights, or at least access to the password if you happen to know the password.
Okay, another question came up. Is there some way to find latency settings? There are no latency settings. The latency is fixed. As we know, all digital devices have latency. I was trying to invent the digital advance, but that hasn't worked out yet. So the latency in our system, regardless of the system size, configuration, number of users, will never change. So there's nothing to set. It's all fixed. And with that, Art, I don't know if there's anything else you need to touch on.
The only thing left was MicroCom, but if we need to, let's just go on.
Let's pass on that. So with that, what I'd like to do is ask Mr. Erskine to join us.
Yes.
All right, so I'd like to actually, we talked about this earlier, I'd like to let Tom and Mark pop on too, but maybe you could talk about some of your experience that we were talking about earlier and people's concerns about, the unknown, etc.
I had first seen CrewCom several NABs ago, and was very excited about it from a lot of standpoints. The main one was the modularity of the system, and so I was at, and I noted when I saw the prices of the systems that a 2-channel control unit with 1 antenna and 4 2-channel belt packs it's pretty much the same cost as a BTR. So for clients that are thinking, oh, well, I've got to replace my BTRs, well, bingo, you go right there. But it gives them the capability of expanding infinitely in all different directions. I worked on 2 shows after that. The first one was with CP Communications. It was a sporting event where the venue was located in a building that was 600 feet from the truck compound. And 2 things we did. First of all, they had tons of fiber. We put all the antennas around with fiber, easy. But the antenna that was right outside the door on the side of the venue building going to the truck compound, we put a transceiver with Yagi antennas on it, pointed towards the truck compound, which you can do because the antennas are removable. And we did the same thing up at the truck compound and had absolutely flawless communication in the 600 feet as we walked up over a hill and down a road over to the truck compound. So that was great. And then in the truck compound, we had 3 trucks and 3 trailers with fly packs in them. And initially we put 3 antennas out there, and we had a complaint that it didn't work too well inside the trailers. Well, I just took 1 antenna of each of the 3 transceivers. And although this is technically not the way they normally work, I just put 1 antenna inside and 1 antenna outside, and it totally cleared up the whole problem. If I'd known that before I got there, I would have specified a transceiver to go inside the truck and 1 to go outside the truck. And in fact, the 2 trailers, I just took that 1 antenna and put it through a passive RF splitter and put it into 2 antennas in the 2 trucks to extend coverage into those trucks, and it worked terrific. The other show I did was New Year's Eve, and we had a production company that had never used CrewCom before and was a little nervous about using it. Typically, this show, I'd done it for several years already. It had 3 stages, 2 stages down on the ground in Times Square, and the other stage was where they actually dropped the ball. And they needed 4 belt packs or 4 belt packs on 1 stage for stage manager and 2 belt packs on another stage for stage manager. So we used the first year we used BTR, second year we used RAD, and that was fine. We put them out; they're all great to go. And I had tried to convince them to use CrewCom, but they said, well, we haven't really used it. We'd have hardly any need for comm on these stages, so why bother? But Tom allowed me to borrow a small system, which I brought along and interfaced to the truck. And we had this, what you see on the screen right here, basically the system. And one of the things which you didn't touch on, and I don't think you did, is if you don't program it in the software, it won't work when you plug it in. Is that still true?
No, it's not. Well, you can program now and not fill all the slots if you want.
But right. If I don't put an antenna on there showing connected and I plug an antenna into a splitter to that slot, it won't work until I program it. Right.
That's right.
So I think the ultimate goal is for a piece of hardware to be self-recognized. But what I did in this diagram right here is I over-programmed my need there. I only needed 1 antenna at the truck, which was on the first copper splitter, and I only needed 2 antennas at 1 stage, 2 antennas at another stage, and 1 antenna on the roof of 1 Times Square. And those were all run over bidirectional SFPs, fiber, a single fiber to each stage. And that's why I used 2 copper splitters so I could jump into them and get 1 fiber out of the CU, 1 fiber out of 1 copper splitter, and another fiber out of the other, and go to 3 different stages. Now there's a fiber splitter, which at that time there wasn't. And so we're going along with the dress rehearsal. We didn't even get to this before that. And one stage, and this stage was located in 1 Duffy Square, which is on the, if you're familiar with Times Square, there's a huge stadium-like platform over the TKTS booth where they give out free tickets to go to Broadway or cheap tickets. And right next to that stage was the back of house for the Duffy Square. And the director said, okay, now take the camera up to the platform on the TKTS booth and we'll cover you walking all the way down the block and into the venue. Well, if we'd known that in advance, we would have brought extra antennas and splitters for the RAD system, but we didn't have them. We just basically had the 2 antennas off the base on the stage, which was on the other side of the stadium for the stage. And so at that point, I said to the production company, well, I happen to have another intercom system interface that can easily do this if you don't mind using it. And they said, oh, okay, fine. So I took the one antenna up on 1 Times Square, brought it back down and plugged it into one of the over-programmed slots for that particular stage. It became the 3rd antenna on that stage and put it over by where the truck was going to go. And this all happened during, actually in the middle of dress rehearsal. And then they were finally, I had it there before they actually did this walk and it worked fine. And we went with it. And it was, after that, they actually said, gee, we should have used that for the whole comm system. And in actuality, because I had it installed already at the other sites, all the A2s used the belt packs, which they weren't supposed to have wireless belt packs, but they used it on the other stages for themselves. So it was really, really a terrific device. And the fact that you can over-program your design, all it means is if you don't put a transceiver there, it's going to be grayed out and it won't work. But as soon as you plug the transceiver in, comes on, it works. And I think that, I mean,
if I may, we're about to release a new version of firmware, software for the system. And part of that not only allows you to kind of over design for it, but you can now hot plug the devices in.
So it will at that point recognize a new piece of hardware.
Right,
That's
so
nice.
you can pretty much program every port for a couple of daisy chained transceivers and kind of plug in anything anywhere and it'll work. But
it still won't allow it to work if nothing's been programmed on that port yet.
That's correct.
That is correct, but you can, what Gary is saying is before we recommended that you bring the system down before plugging in a new device. Now you can do it while the system's live. We handle all of those things. And as long as it's been programmed into the software, it comes up and runs seamlessly.
Ignorance is bliss because I've been hot patching those antennas every time I've used it. So it's no big deal.
Well, the thing is, Peter, it works about, in old software, it works about 98% of the time, but now it works 100% of the time. So that's a good thing.
There we go. Perfect. Perfectly. And I think one of the considerations or one of the objections to going to this new comm system by the production company was that it was digital and it would have latency. And I tried to point out that latency really is not important in a comm system. If you have an extra 100 milliseconds or even 200 milliseconds of time in your comm channel, but they were that's one of the reasons they wanted to have an analog system. Well, nobody noticed any latency whatsoever on there, so they actually said let's use this next time.
So speaking of that, perfect time to switch over because we have a couple more questions.
Yeah.
And one of them is about, is side tone generated locally at the packs? And the answer is yes. And that's because you have to do that in all digital packs or you will hear some echo back. Next question, I'll let Tom take care of this one, which is what is the latency?
It depends on where you are in the system. It'll be constant for you wherever you are. But say if you are a wireless belt and communicating with a wired intercom channel, your latency is going to be somewhere in that 40 to 50 millisecond range. If you're a wireless belt communicating to another wireless belt, it's going to be in that 100 millisecond range.
Okay. Can you have 2 computers connected at the same time?
Not right now.
All right. Frankly, the easiest way to do that is using something like TeamViewer.
That's right.
You have multiples on. We do have a plan to implement that, but it's not current. And then one more question, which is, are we not going to talk about MicroCom? Honestly, this ran a little bit longer than we expected, so I'm going to work with Peter and Kelly and the crowd and set up a separate MicroCom presentation.
Definitely. I think it deserves it anyway by itself because it's a great little product. And
the last piece, Pete, you can talk about this one too because you did last time, and Art can show you, or Tom can show you, which is our little Flex LR.
I'm going to cover the rest of this belt pack so you don't actually see what it is. But this is a belt pack from a company that has a male XLR on it. And I was on a show that the guy that got this belt pack had his own personal headset, and he had a male XLR on it. So I got a whole bunch of these little things, and these are ideal stocking stuffers. Get dozens of them and give them to your relatives. They're wonderful. It's just basically got it's like a male, or rather a female, and they also have a version that it's 5-pin to 4-pin. And this is what CrewCom made to make their belt packs plug into any kind of connector. It's a terrific little device, and it's tiny. Usually you end up with a pigtail 5-6 inches long dangling out there with 2 XLRs on it. It's very messy. So this is a terrific device.
That much of the device sticks out.
10 millimeters in place.
Yeah, when you plug it in, it has a lock that you have to release with a little tiny screwdriver. So actually into the equipment, you need to use a screwdriver and a lot of manual dexterity to get it out, but then has a regular squeeze connector for the cable that you plug into it. Really nice product.
Okay. Another question, is there a specific boot sequence to the systems? Tom?
With the latest firmware, no. We did recommend with previous firmwares that you bring it up in a certain order, but with the latest firmware that'll be released next week, you can turn it on however you like.
All right, and that is called 1.1.
1.8.
1.8.
Sorry, 1.8. I got distracted looking at another question that came up. Question about the audio expansion hub that we had talked about early on.
Yeah, it's in development, but we don't have it ready yet.
Okay.
Now the audio expansion hub won't add more belt pack control, right? It only does.
What it'll allow you to do is bring more 4-wire or 2-wire ports into the device without adding CUs. So a lot of times people need more 4-wire ports, and we're going to bring out an audio expansion unit that has 8 4-wire ports, and then another one that has 4 4-wire ports and 4 2-wire ports.
Ideal. Yep, good.
And Tom, somebody did ask to repeat the latency numbers because they missed it.
Yeah, 40 to 50 milliseconds wireless to wired, and approximately 100 milliseconds wireless to wireless.
All right. And a good friend of mine did a test for me, which I thought was novel in the UK, which is we talked to each other in the same room, looking at each other, and he backed up until they were sequenced, until there was no latency. And as he described it, we have 35 feet of latency.
There we go. Well, you know, I challenge anybody to worry about latency. You just take 2 cell phones and make a phone call between them, and you hear the same latency right there.
Sure, and that's actually a lot more. In most cell phone conversations, you're somewhere between 200 and 400 milliseconds of latency.
Yep.
Okay.
One thing, Gary, that we didn't mention, and I just want to mention very quickly, is that we've been talking about how you can add a control unit and make a system larger, and that's very appropriate in some situations, but in some situations, you have different companies or different organizations operating in the same environment. And in that case, you obviously don't want to combine the systems, but we have what we call a sync port that allows you to synchronize different systems together. There's no audio transfer, there's no interaction from a control, none of that kind of thing. But what does happen is the timing of the hopping is controlled in such a way that all of those systems operate seamlessly from an RF perspective. that can be
Mhm.
really handy at a large event, a sporting event, whatever it
Yeah.
may be.
Let me actually give a real world example. We were at down at Beverly at CBS Television City, and they were doing with American Idol and Dancing with the Stars on adjacent stages with a
Mm.
common work area, common corridor. Each of the stages had completely separate and unique systems. They did not want anything connecting, but with just using a sync cable, which again, no audio, no RF passes, just timing, everything worked cleanly. There was no interference between the stages, and both crews could use the same corridor at the same time without any interaction. And that's one of the ways that we're able to get the kind of density we can at the NBC in New York. Is
Well, I
by
was just going to mention that it just on the third floor, there are 4 studios. We're reusing a number of different hopping patterns. We've got multiple RTs in the hallways and common areas, and each one of those studios has their own system. But since they're synchronized together, we can have those RTs co-located in the common areas without any interaction.
And that's a great question, because it actually goes back to if he's still on, one of our listeners in Australia, our distributor, who asked about a tool to help design. One of the problems is that the environment has such a dramatic impact on RF. It's almost impossible to kind of automate that process. And we have other tools. For example, I gave you specifications of how many transceivers we can use. We can actually reuse and do more things within an area given certain parameters. And when it comes to that, our customers, our dealers, our distributors come back to us, and Tom and the crew get together and help map out what's needed to get the job done.
Yeah, we have, I think, I'm trying to think about it off the top of my head, but on the 3rd floor alone, I think at 30 Rock, I believe we have about 66 or 67 RTs on that floor alone. So again, now that does require a little bit of RF expertise and engineering knowledge, but you can expand it quite a bit.
One thing about the NBC decision, obviously it's great to be able to do that kind of density, but their main motivation wasn't the fact that, at least at the time, we were the only ones who could get that big. I don't know about our competitors now, but they had the simplest belt pack. They could give it to anyone who wasn't a professional comms person, a PA, some star, anybody. And there was zero training, there was zero question. Here's your pack, go to work. So that was
I've had
great.
that experience on shows with that happened to have multiple different wireless digital systems on it. And because your packs are so obvious, 4 buttons, 4 volume controls. You might have to say something about the ISO channel, but most of the time you just said, here's your pack. And the other channels, they had to say, okay, you push this button, here's the volume controls, etc. It's much simpler and intuitive layout.
Okay, we just had one more question pop up, which is a good one. How is a sync signal transported? So if you have 2 separate systems, any network connection from system A, either copper or fiber, simply goes into the sync port on system B. And at that point, it automatically times to it. There's nothing that you need to do other than connect the 2 cables, and they just play nice together.
And actually, it's just 1 cable. So you would take any port on the sync source system, plugged into the sync connection on the master control unit of the second system, and you're done. As Gary mentioned, copper or fiber.
Yeah.
What happens if you don't plug your 2 Pliant systems together with sync?
Then they will operate together okay, but because they will walk relative to each other in time, what you tend to experience is periods of time where there's virtually 0 interaction and periods of time where there is more interaction between the systems. And so you don't have to, but it's highly recommended that you do, just because it'll make the systems perform flawlessly together.
Right. And how far can you transport that sync signal?
6.2 miles over fiber.
Oh, okay. And so is there's on the CU, there's a sync fiber connection?
There is copper and fiber, yeah. So you can come in either copper or fiber into the control unit.
Different than the connection to your hubs.
Correct.
It is a different, that's right, it's a different connector. It's a dedicated synchronization port.
Okay, one more question just came in, a couple more questions coming in. Can we comment on high density mode? They saw that in the configuration. And high density mode is in the plan. It's not ready yet, but we will release a high density mode at some point, which will allow multiple listeners and less talkers at the same time on a transceiver. Tom, you want to talk about the numbers?
Sure, yeah. You'll be able to have up to 32 belts registered to a single RT. You'll be able to have all of those belts will need to listen to some number of conferences. There will be 4 conferences available to any of the people on that RT. And so any of the listeners can listen to any combination of those 4 conferences, and up to 4 of those belts can transmit back into the system at any given moment in time. So if you have spot operators or other people that don't really need to talk a lot, but still need to listen, that really gives you a way to expand user density.
And it is concurrent in that you would have one transceiver for high density and multiple transceivers for standard duplex, all
Sure.
working together.
In a given area, you might have one, what we call a regular normal RT and one high density RT, and you might have your stage managers and some other people on the normal operation mode, and some of your other people who talk less on the high density RT.
Wasn't that available all along?
It was
capability?
not. We talked about it all along, but it is not released yet.
One more question, maybe the last one, not sure, no. Will the sync go through house infrastructure?
No.
It is a proprietary network, so you can pass through our devices, our copper fiber hub transceivers, but it will not go through a standard IP style product. And any plans to make this in 1.9 DECT?
Yeah, as I mentioned earlier before, we are actively and aggressively looking at several different spectrums: 1.9 DECT, 5 gigahertz, 3.7 gig, and potentially others. And we are always developing new radios. There will be more frequencies to come. I can't speak to what the next one will be yet, because I just can't talk about that yet, but we are actively and aggressively pursuing that.
John Christie made a great suggestion that if you could import a PDF of your venue in the drawing underneath your layer, so you can draw your bell packs and your splitters and everything where they actually are in the venue, and that would be terrific.
That's a fantastic idea. It is something that we have on the development schedule, and we've actually played with it a little bit. It's a little more challenging than you would think, but it's something that we would like to do in the future. It's a great idea.
Sure.
Okay.
Kelly?
Well, this was awesome. This ticked the box of, well, which frequency should I operate in? I will take D, all the above, right? That question of where should we be? What should we do? The world we're in right now is everywhere, right? Literally. I mean, that's what we're seeing. Obviously, your applications at 30 Rock show that, and everything across that. I was one of the things with the sync. I actually sent this over to Pete. I realized I typed it in completely the wrong area, but I was thinking, okay, well, what if I have like 2 or 3 of these systems all in use in the same space? You know, I have multiple TV networks, and can I just run a sync between everybody? And then what happens when the sync gets unplugged, right? You know, does everybody just play better and they can still manage their own systems, right? So these are all those future things as we see the density. I don't expect an answer right now, but just that density as we're seeing more and more systems, because that's the one conversation that comes up every single time, which is the fact that I have adjacencies. I have adjacent products off, you know, all operating around me. And when we did our RF Faraday cage match, we came to the quick conclusion that RF coordinators still very much have a role in helping to implement sound RF design in antenna placement and where and how we play
Even if
well
it's not
together.
frequency coordination, you know, you
Right.
need to have somebody say, okay, your CrewCom system is over here and their CrewCom system is over there. Can we get them connected? Or you have to be aware that you may have a little moments of a little jittery noise.
Right. You know, there's a lot of those things that conversations we would have never dreamed of having before, right? Where we go, whoa, 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 leave me alone. I am my island over here. And boy, we're learning in today's world, that island just got a lot bigger.
You know, Kelly,
And
I personally think those days are gone forever.
I think
That
the
we never
job is-
have one really large chunk of spectrum that everybody can just have their own little space in and kind of make things work. I think as we move forward in our industry, it's going to be about how can we effectively use technologies that share the spectrum well, and how can we cooperate in our different venues to be able to utilize that spectrum as efficiently as we can.
Yeah,
Once we get our equipment to work up in the X-ray band, we'll be fine.
There you go.
I think the job changed. You know, for many years, the job was the frequency coordinator, right? He wore the magic wizard's hat.
Yeah.
I think it's a subtle change, but a really important one. It's now the RF coordinator, because it's more than just about frequencies.
yeah. No, this is and that's the point, right? There is nothing, you know, I joke about having automatic everything, but the reality is that's not how it's going to work. Somebody still has to push the button to make the automatic turn on, you know?
That's right.
So,
and honestly, if we don't cooperate well in these venues, but we have a term that was used back in the Cold War, mutually assured destruction. And nobody's going to work. We're so interwoven in these venues now that we really do have to cooperate. We have to do things that make best practices and make sense.
yeah, can't agree more. So on that note, thank you, gentlemen, for bringing this out and spending the time walking us through. I think we had some great questions, and no doubt this is going to spur a lot more questions. And Pete's going to have a number of additional ideas for you. So folks, reach out to them. Don't be shy. Ask your questions. Have a great night. Stay safe out there, and we'll talk to you on the next one.
Thank you, guys. Thanks for having us.
Thanks, everybody.
You're very
Thanks for having us.
Thanks, everybody.
So long.